In the previous lecture, we have discussed the basic of the center of mass for the point objects, truncated body and the continuous body center of mass. Right. Now, I will discuss the motion of center of mass. Motion of center of mass. What is the motion of center of mass? Listen one thing. Suppose we consider the point masses m1, m2, m3 and their position coordinates are r1 vector, r2 vector, r3 vector. What is the center of mass? Suppose the center of mass is over here and this is the RCM vector, right? So RCM vector, yesterday in the previous lecture we have seen m1 r1, m2 r2 dash m1 plus m2. Is it clear or not? Now if we differentiate with respect to time t, drcm upon dt is equal to m1 plus m2, m1 dr1 upon dt plus m2, right, dr2 upon dt, like this. So this is the velocity of the center of mass, m1 v1 plus m2 v2 divided by m1 plus m2 and so on. Is it clear or not? Again, if you differentiate, with respect to time t, with respect to time t. If you differentiate the velocity with respect to time t, you will get the acceleration m1 in the denominator, m1 plus m2 and so on. Differentiation of v1, if it is moving with the speed velocity v1, it is moving with the velocity v2, it is moving with the velocity v3. So center of mass velocity is given by this expression. In the same way, if it has the acceleration a1, it has the acceleration a2 vector, it has the acceleration a3 vector, then what is the acceleration of center of mass? m1 a1 plus m2 a2 plus m3 a3 and so on. So this is the acceleration of the center of mass. Copy this. So in this question, what they have given, suppose the mass is 2 kg, right? This is the mass m1 2 kg and it is moving with the velocity v1 vector 2 I cap plus minus 3 j cap. The other particle is m2 and it is moving with the velocity vector, the m2 is equal to 3 kg and its velocity vector v2 is what? It is I cap plus 6 j cap, right, in meter per second, all right. So their center of mass will be over here and the velocity of the center of mass you have to find. So it is according to this formula we can find, right? So what is the velocity of center of mass? m1 v1 vector plus m2 v2 vector divided by m1 plus m2, right? So m1 is 2 into 2i minus 3j plus 3 into I plus 6j divided by 2 plus 3. It is equal to 5, 2 plus 3, 7i minus 2 minus 6 j cap plus 18 j cap, right? So how much it is this? 7 I cap minus plus 12 j cap. Is it clear or not? Divided by 5, it is 1.4 I cap plus 2.4 j cap. This is the velocity of the center of mass. Are you getting or not? Now in the second part they are asking the velocity of the particle 1 with respect to center of mass. So which is equal to v1 minus velocity of center of mass. Is it clear or not? So what is the velocity of particle 1 with respect to center of mass? This is the v1, 2i minus 3j cap minus VCM mean 1.4i plus, right, plus 2.4 j cap. It is equal to 0.6 I cap. This is minus 5.4 j cap. This is the velocity vector of particle 1 with respect to center of mass. Is it clear? In the same way, the velocity of particle 2 with respect to center of mass is v2 minus vcm. This is the v2 vector, I plus 6j cap, right, minus vcm is 1.4 I cap plus 2.4 j cap. It is minus 0.4 I cap plus 3.6 j cap. Meter per second, it is also in meter per second. So this is the velocity of vector 2 or particle 2 with respect to center of mass. Understood? Please copy this. Okay, so this is the thing. In the with the help of this formula we can find. Listen, one more thing. Although this question remain as it is. For example, suppose this is the ball of the 2 kg and this is the ball of the 4 kg, right? It is moving with 10 meter per second and it is moving with 5 meter per second. Is it clear or not? So center of mass will also be moving with some velocity VCM, right? It is m1 v1, right, 5 meter per second, and this is m2 and this is the v2. Is it clear or not? So in this illustration, right, you have to find the VCM. Second, the velocity of the one particle with respect to center of mass, velocity of the two particle with respect to center of mass. Okay, so what is the velocity of center of mass? You tell. Yes, velocity of center of mass is nothing but, listen, if you assume this is the positive direction, the velocity is m1 v1 vector plus m2 v2 vector. Velocity is a vector quantity. So if you take this positive direction, so this is in this positive direction, this is also positive direction. So I will put m1 v1 m2 v2 divided by m1 plus m2. Is it clear? So 2 into 5 plus 4 into 10 divided by 2 plus 4, and it is equal to 6, 10 plus 40, right? So this is 50, 25 by 3 meter per second. So this is the velocity of center of mass, right? Now the second part, velocity of particle 1 with respect to center of mass, v1 vector minus vcm vector. So v1 vector is positive direction 5 minus vcm vector is what? It is 25 by 3. So it is what? 5 15 minus 10 by 3 meter per second. And the v2 comma cm, velocity of particle 2 with respect to center of mass, v2 minus vcm. Is it clear or not? So what is the v2? It is 10 minus 25 by 3, right? It is 5 by 3 meter per second. Is it clear or not? So this is the v1 and v2. The very simple question, but here you can think that if it is the 2 kg block, this is the center of mass, right? This figure is made with respect to ground, with respect to ground. Are you getting or not? If you are asked to find the figure with respect to center of mass, with respect to center of mass means the figure with respect to center of mass. In the when this is the 2 kg block, you are sitting in the center of mass frame of reference. Is it clear or not? So with respect to center of mass, what is the velocity of 2 kg? You tell. What is the velocity of 2 kg? What is the velocity of m1? It is in this direction. And how much it is? You tell. 10.3 meter per second. With respect to center of mass, what is the velocity of this? Say 5 by 3 meter per second. Is it clear or not? So if you are asked to find the linear total momentum of the system with respect to center of mass, so what will you say? You will consider m1 v1 is equal to m2 v2. 2 into 10 by 3 is equal to 4 into 5 by 3. It is 20 by 3 and 20 by 3. What does it mean? I want to show you that with respect to center of mass, the total momentum of the system is 0. With respect to center of mass, the momentum of the system is what? 0. I want to show you this thing only. Do you understand or not? Are you getting or not? Why it is so? Why it is so? Because you are sitting in the frame of center of mass. When center of mass is at rest, so what will be the linear momentum of the system? Say 0. Also it will come 0. Not only for this example, rather in the previous example, in the previous example. This is the M1 V1. Suppose this is the figure with respect to what? This figure is with respect to ground. But if you sit on the center of mass, this is the center of mass. So this is the M1 V1 with respect to center of mass, and this is the M2, and the mass is M2, and the velocity is V2 with respect to center of mass. So with respect to center of mass, this is the V1 comma C1 center of mass, this is the V2 with respect to center of mass. If you multiply M1 V1 comma center of mass must be equal in opposite direction, right? They must be the equal and opposite direction, M2 V2 comma Cm. You can verify this, always this, because you are sitting in the frame of center of mass, frame of reference. Is it clear or not? Just multiply M1 into V1 Cm or M2 into V2 Cm. These two vector will be in equal and opposite direction always. That is the concept I want to tell you. Is it clear or not? Copy this. Okay, so this thing you will keep in your mind. If for the two particle system, if you are sitting on the center of mass, the linear momentum of the system with respect to center of mass will remain zero. Either, and while the with respect to ground they are moving with some velocities, they would have some momentum. But if the frame of reference is changed, the linear momentum will be zero if frame of reference is your center of mass. Is it clear or not? That is the thing, right? Okay, one more question. For example, if we consider the acceleration, suppose this is the system of the pulley, right? This is M2, this is M1. Suppose M1 is greater than M2. I think you have done this question in your class, I assume. So you have to find the acceleration of the center of mass of the system, right? To find the acceleration of the center of mass, what is the formula for the center of mass? M1, A1, M2, A2 divided by M1 plus M2. Is it clear or not? So for two pulley mass system, two mass pulley system or Atwood machine, if M1 is greater than M1, what is the acceleration? Can you tell? Did you remember the formula directly? Any one of you, did you remember or not? Okay, listen one thing. How to find? This is the M1G, this is the M2G, right? What is the net force is equal to M into A. What is the net force on the system? Say M1G minus M2G is equal to M1 plus M2 into A. So the M1 minus M2 into G divided by M1 plus M2 is equal to A. So the acceleration is M1 plus M1 minus M2 upon M1 plus M2G. Although this is the shortcut, but I think you have done in this way. Suppose this is the T, M1G minus T, net force is equal to MA, right? So M1G minus T is equal to M1A, and for this case, T minus M2G is equal to M2 into A. When you will add equation number 1 and 2, so M1G minus M2G is equal to M1 plus M2 into A. So M1 minus M2 into G, right, divided by M1 plus M2 into A. So this is the acceleration of each block. Its acceleration is upward, its acceleration is downward. Is it clear or not? This is the shortcut, and this is also the technique, right, we have to find. But you have to remember this formula for remember, because it is used many times frequently. Also, the tension, when you will put the acceleration value in one of this expression, the tension comes to be, right, 2m1 m2 upon m1 plus m2 into G. You have to remember the tension in the acceleration. First copy this. If you want to ask, you can, if you want to ask any doubt, you can ask. So if you, this thing we must remember, right? This is the extra work we have done this for this question, because this thing we have done in the NLM. So how to write the center of mass acceleration? M1A1 plus M2A2. Listen one thing, right? You can choose the upward direction is the negative direction and the downward direction is the positive direction. Is it clear or not? So if you consider this the M1, so the acceleration is A, so the A1 vector will be written as the plus A, and this is the A, so the A2 vector, right, it is written to be minus A. Do you understand this thing or not? Because acceleration is the vector quantity and we choose negative and this is the positive, right? So in this expression we can put M1 into A1. A1 is plus A, right, plus M2 into A2. A2 is what? Minus A, divided by M1 plus M2. So M1 minus M2 upon M1 plus M2 into A. And what is the A vector? What is the value of the A? So it is M1 minus M2 upon M1 plus M2 into M1 minus M2 upon M1 plus M2 into G. So answer is M1 minus M2 upon M1 plus M2 whole square into G, and this is the acceleration of the center of mass. So this formula you can remember. Acceleration is this, and if you make the whole square, the acceleration comes out to be of center of mass. Copy this. So in this question, what we have the two equal masses. Okay, the masses are equal, that is good thing, right? And this is the 30 degree, this is the 60 degree. Can you tell me, if this is the inclined, smooth inclined plane it is, right? If the block is released from rest, what the acceleration of the block comes? You tell. Say, what is the acceleration? You did not remember. G sine theta. G sine theta. Very good. This is the G sine theta. How does it come? I am telling you. If this is the mg, this is the mg sine theta. So in this direction, what is the net force? Net force is mg sine theta, which may be written as m into a, is equal to mg sine theta. So acceleration is equal to g sine theta. You will remember. Okay. So what is the acceleration of this block? Say g sine 30. What is the acceleration of this block? Say g sine 60. So this is equal to 5 meter per second square. This is equal to 5 root 3 meter per second square. Is it clear or not? So this is the acceleration of A1 and A2, but acceleration is a vector quantity. So what we assume? If I assume this is the x-axis and the y-axis, right? So how to find the acceleration of center of mass? Say M1, A1, M2, A2 divided by M1 plus M2. So now the A1 will be written in the form in terms of, right, vector. Listen one thing. It is better to assume this is the y-axis and this is the x-axis. You can assume this is the y-axis, this is the x-axis. Is it clear? Okay. Leave that. This is x and the y-axis. Is it clear or not? You may assume whether what is the direction. It depends completely upon you. So if this is the acceleration A, so what are the component? If this is the 30 degree, this is A1. A1 value is 5. Is it clear? This is 30. So this is also 30. So it is what? It is 5 meter per second square. I am writing only 5. This is 5. This is 5 cos 30. This is 5. This acceleration is what? 5 sin 30. Is it clear or not? So what is the 5 cos 30? It comes to be 5 root 3 by 2. Root 3 by 2, and this is x-axis, y-axis. So this is minus I cap, right? This is 5 sin 30, it is 5 by 2, downward direction minus j cap. So what the A1 vector you will write? What is the A1 vector? A1 vector is 5 root 3 by 2 minus I cap plus 5 by 2 j cap. This is the A1 vector. I am explaining it once again. Listen, I think you understand this. G sine theta. This is the 30 degree. So the acceleration will be equal to g sine 30. So it is 5 meter per second square. So for this 5 meter per second square, you will resolve the component. Then you will write in the form of vector. Do you understand or not? Yes. First copy this. So for this thing, this is 5 root 3. Right. What is this angle? This is 60 degree. This is 60 degree. Right. This is 60 degree. Therefore, it is 60 degree. This is 5 root 3 cos 60, which is equal to 5 root 3 by 2, and this is I cap. While this is 5 root 3 sine 60. Sine 60. It is root 3 by 2. So this is 15 by 2. Then you will calculate 5 root 3 into root 3 by 2. 15 by 2, and this is minus j cap. So what is the acceleration A2? This is the A2. In the form of vector, this is 5 root 3 by 2 I cap minus 15 by root 3 j cap. So this is the A1 vector and A2 vector. Now I will put in this case M1 and M2 both are equal. So M A1 vector plus A2 vector divided by 2M, it will cancel out. So what is the center of mass acceleration? A1 plus A2 divided by 2. This is the A1 vector, 5 root 3 by 2 minus I cap, 5 by 2 j cap, plus this is 5 root 3 by 2 I cap minus 15 by 2 j cap divided by 2. Is it clear? I think it is cancel out. And this is how much? Minus 5 minus 20 by j cap upon 2. So this is how much? Minus 5 j cap. The acceleration of center of mass. Right. So if you think the magnitude is 5 meter per second square, vertically down. This is the acceleration of the center of mass of this system of 2-point masses. Copy this. Repeat your question, please.
The final acceleration system for getting 5 3 j cap minus 5 I cap divided by 2.
No. There is some mistake in your solution somewhere. Check your answer. It is A1, it is correct, and A2 is correct. Please tell me first. The A2 you had found, it is correct or not? This is 5 root 3 component. This is 5 component. The 5 meter per second square is the correct answer. It is vertically downward. The thing is that if this is 30 degree, this is 60 degree, you have to find A1, you have to find A2, then you assume this is the x and y axis, this is x and y axis. So this component is minus 5 root 3 by 2 I cap, this is 5 by 2 minus j cap, right? This component is 5 root 3 by 2 I cap, this component is minus 15 by 2 j cap. So A2 vector you can write, A1 vector you can write. Then put in this, M1 and M2 both are same, and you can get the answer. It may be, as I told you, as I am taking this x and y, you can take this x and y, you can take this x and y. If it is better to take x and y in this direction, because they are at 90 degree, it is better to take. I did not care of this. So it is 90 degree. The solution will be easier if you take the x-axis and the y-axis this, because both are perpendicular. So if the acceleration A1 will be equal to, directly it may be written as 5 I cap, all right, and acceleration A2 vector directly can be written as 5 root 3 j cap. So the solution given in the book, right, it is easy as compared to me. But if sometime it is 30 degree, it is 30 degree, then it is not possible. You have to do in this way only. But for this question, you can go through like this. This is A1 vector, this is the A2 vector. So the mass is m, the mass is m. Again, if mm is same, so the what is the acceleration of center of mass? Say A1 vector plus A2 vector upon 2. So A1 is what? 5i, 5 root 3 j cap divided by 2. Is it clear or not? So this is 5 by 2 I cap plus 5 root 3 by 2 j cap. Although this is the acceleration, if these are the 2-point mass, the center of mass will be moving in this direction somewhere. But if you take the magnitude of the center of mass, 5 by 2 whole square plus 5 root 3 by 2 whole square ka square root. Is it clear or not? So this is how much? 25 75 upon 4, right? So it is 25 is equal to 5 meter per second square. So in this way also you can do this question. It is all the long method, but it is also correct, and you should adopt this, because in this special case this is 90 degree. So choose x-axis and y-axis along the inclined plane. It will be better for this question, right? Suppose I'm coming to that point only, right? If this is the 2 kg block, this is the 4 kg block. Suppose it is moving with 5 meter per second. The center of mass will be there. Find, if it is x-axis, the y-axis, find velocity of 4 kg block, right? So that center of mass remains at rest. Can you find? Right. This is the question. How to find the solution? Okay, how to find the solution? Velocity of center of mass is assumed this is the positive direction. So it is equal to 2 into 5 plus 4 into V2. I don't know. 2 plus 4, and it is equal to 0. So 0 is equal to 10 plus 4 V2. So V2 is equal to minus 10 upon 4 minus 2.5 meter per second. What does it mean? It has to move in this way. Listen one thing. This is the 2 kg, 5 meter per second. If the center of mass at rest, right? What does it mean? If it is 4 kg, it must move in this direction 2 meter per second. Are you getting or not? 2 into, listen, 2 into 5. This is the linear momentum, and 4 into 2.5. The linear momentum is equal. It is also 10, it is equal to 10 in equal and opposite direction. Is it clear or not? So the center of mass is at rest. Listen one thing. What is the velocity of center of mass? Say 0. What is the momentum of center of mass? Total mass into VCM. It is also at rest. It is also 0. Are you getting or not? Listen one thing. Suppose this is the M1, this is the M2, right? And this is the position of center of mass R1 and R2. Can you tell me what is the relation between M1 R1 and M2 R2? If it is center of mass. What is the, if this is the center of mass for 2-point mass system, M1 R1, M2 R2, what is the relation between them? Yes, M1 R1 is equal to M2 R2, right? Yesterday I told you this. Are you getting or not? Right. Also, if you differentiate this with respect to T, so M1 V1 must be equal to M2 V2. If this is the V1, this is the V2. Is it clear or not? Center of mass remain at rest. It must be the answer. Or in terms of vector, in vector form, if it is V1 vector, the momentum must be equal to V2 vector. How does it come? Because if the center of mass is rest, so the momentum of center of mass of the system, you can say. The momentum of system, what is the momentum of system? m1 v1 plus m2 v2 must be equal to the null vector m1 v1 plus m2 v2, and from this you will get this relation. From this relation in magnitude you get this relation, or you can say this relation. Also you can do it in reverse way. Yesterday, if center of mass is, this is the center of mass position, r1 m1 r1 m2 r2, you can get this relation by differentiating. In vector form you can write in this direction, because the velocity vector are in equal and opposite direction. Is it clear or not?
Yes, sir.
Copy this. Now I'm making the basic to solve that type question you are asking, right? For example, listen one thing. m1 r1 m2 r2 you must remember, m1 v1 m2 v2 you must remember if center of mass is at rest. Are you getting or not? For example, one more question. If this is the 2 kg and this is the 6 kg, suppose. Are you getting or not? So this is the thing. It is the center of mass position, suppose, right? And suppose the 24 meter is the distance between them. I think you can find r1 and r2 easily, right? By the using the formula. Listen one thing. If this block move in this direction, right, by 2 meter, if it blocks by 2 meter, is it clear or not? So by what distance 6 kg block must move in the same direction so that the center of mass remains on the same position? This is the question. In the figure you can write the question. If 2 kg block move by 2 meter, right, find the distance moved by 6 kg so that center of mass remains at rest. You may assume the distance between them is r. Are you getting or not? This is the question. Copy this. The center of mass should remain at the same position. So I am giving the solution. Very interesting. Suppose this is the m1, this is the m2, the distance is r, center of mass will be somewhere. All right. So if it move by x1, so the m1 comes at this point, it move by x2, so that the center of mass remain on its position. Is it clear or not? Tell me.
Yes, sir.
If right, so it remains at the same position. What is if this is r1, this is r2? Are you getting or not? Now this is r1 dash, this is r2 dash. Can you tell me what is the relation, initial relation, when they does not move, right? What is the relation between m1 r1 and m2 r2? You tell. M1 r1 must be equal to what? M2 r2. Now center of mass on its same position, it move by x1, it move by x2. Is it clear? Now it is r1 dash, is it r2 dash? What is the relation between m1 r1 dash, m2 r2 dash? M2 r2 dash. What is r1 dash? Can you tell? It is r1 minus x1, it is r2 minus x2. Multiply m1 r1 minus m1 x1 is equal to m2 r2 minus m2 x2. They will cancel out. So what is the relation? Say m1 x1 is equal to m2 x2. That's it. Is it clear or not? So I think you can do this question. You have to remember also, suppose this is the 2 kg block, it is moved by x1 2 meter, the center of mass will be over here. This is the 6 kg block. What distance it has to move so that center of mass remain on its same position? It is 2 kg, right? It is moved by x2, it is 6 kg. I think you are getting the solution now. This is m1, this is m2. Tell me what is the answer you will tell. Say m1x1 must be equal to, say m2x2. Getting or not?
Yes, sir.
So m1 is what? 2 into 2 must be equal to 6 into x2. So 4 upon 6 is equal to x2. So x2 is what? 2 by 3 meter. Is it clear or not?
Yes, sir. Yes.
Right? So there is very important relation. m1 r1 is equal to m2 r2 is also correct. If this is the m1, this is the m2, move by x1 and x2, what is the relation in that also? m1 x1 is equal to m2 x2. Is it, are you getting or not?
Yes, sir.
If you differentiate this, so m1 v1 must be equal to m2 v2. If it is moving with the speed v1, it is moving with the speed v2, what should be the relation between m1 v1 m2 v2 so that center of mass remain at rest? Say m1 v1 is equal to m2 v2. Are you getting this thing or not?
Yes, sir.
Right? By differentiating this, you can get the relation. Although you may write this is the theory and this is the solution of that question. Now by looking only, you can solve this type of question. m1x1 is equal to m2x2. No need to do this theory, but at least once you have to go through this, right? One more question of the similar type. Listen one thing. The concept I am telling you, if there is a 2 block system or 3 block system, if external force on the system is 0, right? What is the external force? Rate change of momentum of the system. Then if external force is 0, dp upon dt is 0, it means linear momentum remains constant. Are you getting or not? That is, if center of mass of system is at rest, right? It will remain at rest. It will remain at rest if no force is applied on it. If no external force is applied on it. Are you getting or not? For example, first I am giving you the theory, you can copy this. Very good example. Although this is the language, English language, you cannot understand if a very good illustration you don't have. Suppose this is the capital M, this is the person, and it is tied with a tension T. The mass of the person is M. Definitely the center of mass will be, right? Suppose this is the capital M. The center of mass will be at this position somewhere. Suppose the distance is L. Are you getting or not? Listen one thing. No friction is everywhere. No friction. If you consider the only x direction, so when this person, right, pull this string, so what will happen? The tension will be there. So if person is pulling this plank, what will happen to this block? You tell. How many force will upon this? Mg and normal and tension. Are you getting or not?
Yes.
So what will happen with this block? You tell. It will move in this side or not?
Yes, sir.
It will move. Why it will move? Because tension is acting. So if acceleration is A1, right? So net force is equal to capital M into A1. Is it clear or not?
Yes.
What happened to this block? This person, this is mg and normal. Tell me. If no friction is 0, no friction is over here. The tension T is acting on this block, on this person. So what will happen to this person? if you are pulling a block on the frictionless surface, because of this tension you start moving in this direction also, such that the center of mass remain on its position. So if this block move by the distance x1 with acceleration a1, are you getting or not? Center of mass will remain on its position and the person will also move in this way, and this is the string, remaining string, such that if this is the x2, so if this is m, what is the relation between? I told you, say m1 m into x2 is equal to capital M into x1. This is the one relation.
Yes.
What is the acceleration a2? The t is equal to m into a2. Do you understand or not?
Yes.
So tension are equal. So if tension and tension are equal, right, what will you write? ma2 is equal to capital M into a1. Are you getting or not?
Yes.
Also, if it acquires some velocity, so mv2 is equal to what? Capital mv1. Are you getting this thing or not?
Yes. Okay.
But center of mass will remain at rest. Is it clear or not?
Yes.
Copy this. Listen one thing. So I can give you the example. Suppose this is the 100 kg block and this is the 20 kg block, right? Oh, sorry. This is the 20 kg person, chalo 30 kg person, right? 20 kg only. And it is pulling. The initial distance is 10 meter. Are you getting or not? So center of mass will be somewhere. So when this is the 10 meter rock, find the distance moved by person and block when person touches the block. Do you understand the question? Tell me. When it is pulling, it will touch definitely. No friction is everywhere. It is understood. No friction is everywhere. So when he is pulling, so sometime when they will meet, where they will meet? Tell me. Where they? At the center of mass. So it is very simple. So when the person and the block reaches over there, right? What is the distance covered by the person? Say R1 only. What is the distance covered by the block? Say R2 only. And R1, although you can write directly, right? So R1 plus R2 is equal to what? 10 meter. Also, what is the another relation? Say M1 R1 is equal to M2 R2. So this is M1, this is M2. So what is the M1? 20 into R1, 100 into R2. R1 is equal to 5 R2. So this is 5 R2 plus R2 is equal to 10 meter. R2 is equal to what? 5.3 meter. Is it clear or not?
Yes.
And what is the R1? 5 into 5 by 3. It is 25 by 3 meter. Is it clear, Parshaz? This is the one way. Or directly R1 is equal to what? Say M2 upon M1 plus M2. Yesterday I told. Directly R2 is equal to M1 upon M1 plus M2 into R you can write. You will get the same answer. Copy this. Listen one thing. Listen one thing. Now you tell me. For example, suppose there is a plank, right? It is placed on the frictionless surface. It is 100 kg suppose. And the person is on, this is the 40 kg. Are you getting or not? There is no friction between plank and the surface, but there is a friction between person and the plank. Suppose this is the 5 meter. Suppose this is the 6 meter. Okay. Are you getting or not?
Yes.
When the person start moving on it, what will happen? You tell. When the person start moving on it, so the friction force between the foot and the plank will act on the plank. Is it clear or not? You tell. And because of this, what will be the motion of the plank? Forward, opposite, in the backward direction. And the same friction will be acting on the foot of the person. So this person will move in which direction? Right. So after some time, what will happen? Tell me. When it will move, it will start moving. So the person reaches to this point and the plank is moved. So in some question, they ask what is the displacement of the plank. Are you getting or not?
Yes.
Right? This is the question. Is it clear or not?
Yes.
Listen. Suppose this is the 6 meter or 10 meter, whatever. Listen. When it is moving on the plank like this, it is moved like this, right? And finally it reached to this point. Listen one thing. If suppose this is the M2, so this M2 is moved by what distance? Say x2. Are you getting?
Yes, sir.
And this is the M1, it is moved by distance x1, so that center of mass remain on its position. Are you getting or not? If this is the 40 M1, this is the M2, where is the center of mass? The center of mass will be this point. This is the center of mass. This is the initial center of mass. When it moves slight little distance, the center of mass remain on its position. Are you getting? When it completely move this way, center of mass position does not change. Are you getting? Why does not change? Since external force on the system is 0, so center of mass does not change. What is the relation between m1 x1 and m2 x2? m1 x1 is equal to m2 x2. Are you getting or not? So if it is the x2, it is the x, what is the displacement of the second mass m2? This is the 40 kg mass. It is m1. Suppose this is the x1, I am assuming this is the x2. Are you getting?
Yes, sir.
So if this is the m2, so what is the relation between capital X1? This is the big displacement, m1 x1. m1 x1 is equal to what? M2. x2 is the complete displacement, final displacement of the plank. So what is the m1? Say 40. It is x1, right? It is 100 into x2. So 2x1 is equal to what? Say 5x2. Is it clear or not? You tell.
Yes.
And what is the x1 plus x2?
6 meters.
x1 plus x2 is equal to 6 meter. So we have to find x2. So from here it is 5 by 2 x2. So x1 is 5 by 2 x2 plus x2 is equal to 6. Right. So we can find 7x2 is equal to 12. So x2 is equal to what? 12 upon 7 meter. And then you can find the x1 also. Do you understand this question or not?
Yes.
So this is based upon only this m1 x1 is equal to m2 x2, right? This is the one method to solve this question, but this is the very interesting method, right, to solve this type of question. But we have another method which is also very important.